Guys, today we're going to be looking at angle geometry, which I had started with you yesterday in class. At the top here you see a diagram of two intersecting lines. One important thing is you need to be able to name your angles. So if I wanted to name this angle over here, I would name it angle AEB. You have to use three letters, sort of tracing the path of the angle A to E to B. If I wanted to name this angle down here, I would name it angle DEC because it goes D to E to C. Okay, and we need to know some angle relationships. So the two angles that I just named are examples of vertical angles. Vertical angles are across from each other, and they share a common vertex, meaning that they share a point. So an example would be angle AEB and angle DEC. Or another pair of vertical angles is the two green angles that I'm highlighting, angle BEC and angle AED. And vertical angles will always have the same measure, so they're congruent. That means that if angle AEB measures 73 degrees, then this angle would be 73 degrees also. Supplementary angles, if you remember our angles that add up to 180 degrees, what that looks like is a straight line. So if you have two angles divided up into two sections, the sum of them is 180. That makes them supplementary. They'll look like a straight line. So if you look at the diagram, I'm highlighting in black this line, these two angles together, DEA and AEB. Angle DEA and angle AEB together form a straight line. They're supplementary. So if AEB is 73 degrees, then I know that the other angle, DEA, must measure 100 and, I'm trying to subtract 180 minus 73. So it would be 107 degrees. Okay. So what you're going to see is you're going to see algebraic equations being used for these instead of just numbers. In example 1, I tell you the measure of angle DEC is 3x plus 5. So what you want to do is you want to find that angle, DEC is over here, and put the expression in it. And BEC is 2x plus 15. That's over here. BEC is 2x plus 15. And look at the relationship between those two angles. Are they vertical? Are they directly across from each other? No. They form a straight line. So together they're supplementary. So what you do is you take the two expressions and you add them up and you say these must add up to 180 degrees because they're supplementary. And then you combine like terms. 5x plus 20 equals 180. Subtract the 20. 5x equals 160. Divide by 5. X equals 3, 15, 32. Once you find x, some questions just say find x. Some questions ask you to find a particular angle. This one says find the measure of angle AEB. So AEB is up here in yellow. Well, first I would have to find, I know that it's vertical with the red one, 3x plus 5. So if I could find that one, then I know AEB will be the same measure. So I'll multiply 3 times 32 plus 5. So 3 times 32 plus 5 is going to give me 96 plus 5, which is 101. So that's going to be 101 degrees. Each question asks you to find something different. But first you need to just find x. Okay, the next one, example 2, the measure of angle AED is 3x plus 20. Again, just find the angles and put the information into it. AED is here. That's 3x plus 20. And BEC is 2x plus 40, that's here. These share a common vertex. They're across from each other. These are vertical angles. Vertical angles are always congruent, so I set them equal to each other. I say 3x plus 20 must be equal to 2x plus 40. They're the same angle, so I'm going to solve for x. I'm going to subtract 2x. I have x plus 20 equals 40. Subtract 20. X is 20. Some questions will just say find x. Other questions will ask you to find a particular angle. This one says find the measure of angle DEC, and that little m again means measure. So I'm going to find DEC, which is here, and say, well, that is supplementary with this. So if I find BEC first, and then subtract from 180, I'll be able to find the missing DEC. So 2 times 20 is 40. I'm plugging into this. 2 times 20 is 40 plus 40 is going to give me 80. So if this is 80, then DEC is 100 degrees. Okay, next I'm going to look at situations that are that all look like this, where they're called parallel lines cut by a transversal. Parallel lines cut by a transversal. So parallel lines cut by a transversal look like this. I'm showing you two examples here that I'm circling in green. There are two parallel lines, and they're cut by another line that's diagonal to it. So P and Q are being cut by L, or in the bottom example that I'm highlighting in blue, L and M are parallel, and they're being cut by N. And when you cut them by a transversal, you're creating these angles that have these relationships that we should know. So scrolling to each type of angle now. I'm going to show you examples of each type of angle. So vertical angles we just talked about, they can exist in these parallel lines cut by a transversal. Vertical angles would be like 1 and 3, or 5 and 7, or 6 and 8, or I'm running out of colors here, or 2 and 4. Those are vertical. Vertical angles are congruent. They're the same measure. Adjacent angles. Adjacent means next to. Next to, sharing a common side. So angle 1 and angle 2 are adjacent. They're next to each other. They share a common side. 4 and 3 are adjacent. They share a common side. Also, you could look at it like 1 and 4 are adjacent. They share a common side. They basically create a straight line together. So these lines, these angles form a straight line, so they are supplementary, meaning that they add up to 180 degrees. Another angle relationship that we should know is corresponding angles. In this picture, they're already, I found this little image, it's nice, they're already highlighted for you in different colors. So the ones that are in blue, N and R, are corresponding. Corresponding are in the same place. So if you look at the top 4 angles and the bottom 4 angles, N and R would fall on top of each other. They're in the same location. Or the green ones, O and S, are in the same location. They're corresponding. Or the red ones, M and Q, are corresponding. They're in the same place. And the yellow ones, P and T. So corresponding angles are also always congruent. Okay, they are the same measure, congruent. Alternate interior angles. Alternate interior angles means that they are on the inside of the parallel lines, and they are on alternating sides. So alternate interior angles would be like angle 4 and 6. They're on the inside of the parallel lines, and they're switching, alternating sides. Or angles 3 and 5 are also alternate interior angles. They are also always congruent. We have alternate exterior angles. Those are on the exterior, on the outside of the parallel lines, alternating. So angles 1 and 7 are alternate exterior. Angles 2 and 8 are alternate exterior. And they are also congruent. They're the same measure. Consecutive interior, also known as same side interior, means that you're on the inside of the parallel lines, but you're on the same side. So like angles 4 and 5 are same side interior or consecutive interior. Also, angles 3 and 6 are same side interior. These are supplementary. They add up to 180. And you could see the shape of them. You could see that angle 4, for example, angle 4 is open up wide. And angle 5 is not. It's acute. It's leaned in. They're not the same. Together they add up to 180 degrees. They're supplementary. So what you're going to see is algebraic equations that you have to set up for different situations. So in example 1, for example, you have to first figure out the relationship. This angle and this angle are in the same position. These are corresponding angles. And you could see they're like the same shape. They're congruent. So you would set up an equation that says 12x plus 3 is equal to 11x plus 9. And you would solve for x. So subtract 11x. I have 3x plus 3 equals 9. Subtract 3. I have x equals 6. Now from there, you could just, sometimes questions will ask you to solve for x. Sometimes they'll ask you to find particular angles. In all of these questions, I think I kept them all the same, where it says find the measure of all eight angles. So you would take your 6, plug it back in. So 12 times 6 is 72 plus 3 is 75 degrees. If that's 75 degrees, then you know this is 75 degrees. The vertical angles are 75 degrees. And then when you subtract from 180, then this is 105 degrees. And then this has to be 105 degrees. And this has to be 105. There's only 2 measurements in the whole thing. Okay? So it's really easy to figure out what the relationship is. I'm going to stop this and do a new video because it's going to cut short.